I am Anil Kumar. Welcome to my series on quadratic functions. In this video, we will learn how to graph inverse of quadratic functions. I have taken three examples. We'll first draw inverse using quadratic function in vertex form, and then we'll take up an example where the graph of the quadratic function is provided. And the last example will be when the equation is given in the standard form. You can always pause the video, sketch the graph, and then look into my suggestions. Let's begin with the very first question, where we are given equation in the vertex form. We need to graph this function. Minus 2 x minus 1 whole square plus 3. Now if we are given the vertex form, it's kind of simpler to sketch the graph. We know what the vertex is. 1, 3 is the vertex. So let's place this point on the graph paper. 1 and 3, right? So that becomes the vertex. Now that minus indicates that the graph is going to open downwards. We will use steps to sketch the rest. Normal steps for any graph y equals to x square is 1, 3, 5, 7 and so on. We are going to multiply this with the a value, which is minus 2. That means the graph is reflected on the x-axis and there's a vertical stretch by a factor of 2. It really means that if you move 1 unit to the right, you have to now go 2 units down, right? So we'll get the other points. So if I move 1 unit to the right, I have to go 2 units down. Next unit, I have to go 2 times 3, 6 down, where the negative sign means down, right? So next time, 1, 2, 3, 4, 5, 6 units down. Now, we know this is also the axis symmetry, so we can get the other points just by using the symmetry, correct? So we have a graph here, which is a parabola opening downwards, right? So that is how you're going to draw this particular graph. So we have done the first step, that is to graph the function. Now the second part of this question is determine the equation of inverse of this function, right? So A is done, B. To find the inverse, as you know, we have to swap x and y values and then isolate y, right? So f of x equals to minus 2 x minus 1 whole square plus 3. We'll write this as x equals to minus 2. Replace x with y minus 1 whole square plus 3. Now we need to isolate y. So we'll first subtract 3. So we get x minus 3 equals to minus 2 y minus 1 whole square divided by minus 2. So we get x minus 3 divided by minus 2 equals to y minus 1 whole square. And then we'll square root it, right? So we have, let me do it on the right side, rest of the portion. So we can say this is square root of x minus 3 over minus 2. And whenever you square root, you have to write plus and minus y minus 1. Bring 1 to this side. So we get 1 plus minus square root of x minus 3 over minus 2 equals to y. Now this is inverse. Definitely it is not a function. We have plus and minus value. So you can write f inverse is equal to, we are used to writing plus minus first, right? So we'll do it in standard way as you normally write. And we have this plus 1. So that becomes the inverse of this particular function. And we see that inverse is not a function, right? And that leads to our D, which is state restrictions on the domain of x to make inverse to be a function. It is not a function. We need to restrict domain to find this. We'll do it later. Let's first do part C, which is graph f inverse x. Okay, now to graph f inverse x, what should you do? Well, to graph, we know we have to reflect our graph on the line which is y equals to x, right? So y equals to x is kind of this line which goes diagonally, right? So which goes kind of diagonally. So I'm just sketching a light line here which is y equals to x. So we have to reflect all the points on y equals to x, correct? So let's begin with the vertex itself, which is at 1, 3. So that point becomes 3, 1, right? So for 3, we get 1. So this point gets reflected to that point, right? So this is vertex 3, 1. Now we had the point here, which is actually 2, 1. So it becomes 1 and 2, right? So 2 and 1 will become 1 and 2. So 1 and 2 means that point. From the symmetry, we can always go down and take this point here also. Is that clear to you? That point reflection. Is it clear? Now the point here was 1, 2, 3 and then 1, 5, right? Minus 5. So we'll go minus 5 and 3. So minus 5 and 1, 2, 3, right? So that's what it will be. And then symmetrical, this point will be, this is at minus 1, minus 5. So at minus 5, minus 1. Clear? So do you see we have our inverse function, right? So we have a parabola reflected on the left side, kind of like this. So that becomes inverse. So you see how we have sketched the inverse of the function without even calculating any point. We also sketched the parabola without calculating points, just from the characteristics. That's the beauty of this. Do you get the idea, right? Okay. Now the last part here, part D, is state restrictions on the domain of X to make the inverse to be a function. Highlight the restricted graphs. Now, as you know, this function which we have sketched fails horizontal line test, and therefore the inverse is not a function. So we'll do part D here. To restrict, we will consider only one part of it. So let us consider the part which is on the right side. Okay, so if I consider this portion, so we have to highlight, right? So the restriction here is that, so on the f of x, the restriction here is that x is greater than 1. So if I have that restriction, in that case, the graph of the parabola which I am considering is this one, right? So in that case, the inverse will be a function. Now you can say when x is greater than 1, that becomes a domain. We know that y is less than, let's say greater than equal to, less than equal to this point, which is 3. Now you should understand that the inverse domain and range will swap, right? So we are now looking for x less than equal to 3 and y greater than equal to 1. So that also helps you to figure out which one of these is your right graph, right? That is another thing, right? Other thing is very clear that from this graph, the inverse is, we are looking for these points, so they are going to which portion, correct? So clearly, you can see from here that y is greater than equal to 1. That means we are talking about the upper part of our inverse. Do you see that? So we're looking into this part of our inverse, right? Otherwise, you can always remember that if you are restricting to the right hand side, it is the upper portion of the parabola which is showing left. So I hope that helps, right? So we have done part D also, and that is how you should be sketching the graphs of your quadratic functions, inverse and their graph, correct? Now let me summarize few things which we have seen in this particular example, and I'll put them as a note here. So the note here is that if the parabola opens down, inverse open left. if the parabola opens down, inverse left. Is that clear? That is first restriction. You see, parabola opens down, the inverse opens left side. Now, if restriction is of the right side, if the restriction is x greater than equal to the vertex value, let's say in this case we took this as 1, right? In that case, we are looking into upper part of f inverse x. Do you see that? So if we use greater than equal to, in that case, upper part of the parabola is what we have to look into as the inverse of the graph, right? So I hope this concept is absolutely clear. Now let's move on and take the next example, where we are going to sketch the inverse from the given graph. So this is the graph of a parabola. As you can see, in this particular graph, we have already restricted the domain, so it is half the parabola, right? I would like you to answer this question now and then look into my suggestions. Now let us answer the second question, which is graph of quadratic function f is given below. Sketch the graph of f inverse. Well, I changed the question a bit. We have divided into 4 parts. First is determine the function f of x. Then we need to graph inverse of the function and then determine equation of f inverse x. Write domain range of f inverse x, right? So these are 4 parts which we are going to do. So first, let us find what this function is. Now here, it's a parabola given to us. We know that the vertex is at a point which is minus 2, 3, right? So this point here is minus 2, 3. So that is the vertex. That means we get x plus 2 whole square plus 3. Now, it is opening downwards, and therefore, we have to have a negative sign. But before that, we have to see these steps. If I move 1 unit to the left in this case, we are going 1 down, and second unit, we are going 3 down. So the steps are 1, and therefore, it is just minus. Is that clear to you? So from these steps and from the vertex, we have found, right? So we have the vertex, which is minus 2, 3, and we have steps, which is minus, I'll write minus 1, minus 3, minus 5, and so on. So we get this minus 1 here. Is that clear to you, right? Now we need to graph this function. So let's graph this function. We are going to reflect each and every point on this line, which is y equals to x. Is that clear to you? So the first point which I am going to reflect is the vertex itself. Minus 2, 3 comes to 3, 2. So 1, 2, 3, and 2. Sorry, 3 minus 2. So 1, 2, 3, minus 2. It makes sense. That is diagonal. Do you see that? Now this point here is invariant point. It is on the graph itself, right? So we have that point. Now this step was 1 down, so it is 1, 2, 3, and so we have minus 3 and 2, so it becomes 2 and minus 3. So 2 and minus 3 will be 1 down, correct? This is invariant point. So that graph is actually going like this. Do you see that? So as you can clearly see, if you have a parabola which is opening downwards, then the inverse is opening on the left side, and on this we are restricted to the left side, so we are going to the lower half of the parabola opening left. So we got this inverse. Is that clear to you? It was that simple. Now, it is important to note that we did go through the invariant point, which is minus 5 minus 5. Okay. This is important point to consider. Okay. Now, we need to determine inverse functions equation. That is kind of important to understand. Now, once again, when I wrote this equation, I should have restricted my domain to the left side only. So the x values here, we have to write x belongs to real numbers, where we can write like this. X is less than equal to minus 2. Now it becomes the equation of the function given to us. So now this is a for us. Is that clear to you? Correct? Now we will do the inverse. We've done part B. Well, let's do the inverse of the function, part C. To find the inverse, we are going to swap. So we'll write this y as x equals to minus y plus 2 whole square plus 3. Bringing 3 to the left side, x minus 3 equals to minus y plus 2 whole square, dividing by minus. So we could actually swap this, but I'm writing this as minus 1 here, equals to y plus 2 whole square, and then we'll do square root, right? So we get x minus 3 over minus 1 square root. Whenever you do square root, you have to write plus and minus. Okay. Now, here is a catch. Let me complete this step as y plus 2. Now, see one thing. When we have restricted the domain, we also know at this stage that what is the range. So here, we also know that y value belongs to real numbers where y is less than equal to 3. So when you are finding the inverse, these domain and range will swap. Now, what are we looking into? We are looking into domain which is less than equal to less than equal to 3. So in this case, when you do this, you should remember that x has to be less than equal to 3. Right? That is one thing. And as far as the y value is concerned, it is going to be less than equal to minus 2. And the y value will be less than equal to minus 2. Now, this is very important to understand, since the domain and range will swap for the inverse function. Correct? Therefore, we are not going to take the plus sign. We are only going to take the negative sign in this particular case. You get the idea? We have taken the graph which is on the left side of the parabola. So we are going to consider only the negative sign here. That is very important to understand, right? So we'll not use plus and minus. We'll only use minus. So bringing minus 2, we have minus square root of x minus 3 over minus 1 equals to y. So we can now write that the inverse is a function and its value is minus square root of x minus 3 over minus 1 minus 2. So that ensures that the range of this function is actually less than minus 2. Does make sense to you? Correct? And now let's write the domain and range of the inverse function. So we've done this part, which is how to find the equation. And now let us find the domain and range of f inverse, which is right there. So we will write domain as now equal to that x value belongs to real numbers. However, x has to be less than equal to 3. And the range, the y values, belongs to real numbers, but y values are less than equals to minus 2, as you can see from here. Okay? This is for inverse function. Now, in this case, inverse is a function, since we have restricted the domain of the parabola under consideration. The graph was given only of one side of the parabola, correct? So the note here is that you need to restrict domain and range of inverse also, as shown in this particular example, right? That is very important to understand. Now here is the last example. It is similar to the first one, except for we are given the equation in the standard form. And now question number 3 is, given f of x equals to x square minus 2x minus 3, graph f of x, determine equation of f inverse, graph f inverse, state restrictions on the domain of x to make inverse to be a function. You could graph using intercept form or the vertex form. Since we need to find the inverse, we should write it in vertex form, right? So note here is, since we need to find f inverse, write in vertex form. That is important, correct? So with that note, let's begin with part A. So we'll write it in the vertex form. We can write f of x is equal to x square minus 2x minus 3. So we can write x square minus 2x. Half of 2 is 1. So we'll add and subtract 1 minus 3. Now these 3 become a perfect square. So you could write this as x minus 1 whole square. And minus 1 minus 3 is minus 4. So what we did was, these 3 are perfect square written like this. And we added minus 1 and minus 3 to write minus 4. So that becomes our function. Perfect. Now, once we have our function, let's find the inverse of the function. So let's find the inverse of the function now. To find the inverse, let's say this is y equals to this. We'll swap x and y. So we get x equals to y minus 1 whole square minus 4. Bring this here. So we get x plus 4 equals to y minus 1 whole square. Square root x plus 4. Do plus and minus equals to y minus 1. And now we can write down its inverse. Y equals to, taking 1 on this side, 1 plus minus square root of x plus 4 is equals to y. So f inverse, it is not a function. So I'm not writing x here, right? So plus minus square root of x plus 4 plus 1. So that becomes your inverse. So I hope this part is also clear. Then we have to graph the inverse, okay? So we have to graph the inverse. So they are not telling you to graph the function itself, only graph the inverse, okay? So in this case, to graph the inverse, we know it is a square root function. If x is equal to minus 4, then this part is 0, right? So the vertex here is actually, will begin with minus 4. Let me just tell you what I'm trying to do here. So first thing is that x values have to be greater than minus 4, right? So if I write x as minus 4, in that case, this inverse function values will be, that will be 0. We get 1 here, correct? So we get 1 point, which at minus 4, we have the value 1. Now, let's calculate. The next good value will be to take this as 3, right? So if I take minus 3, in that case, this will be 1, right? Okay. For minus 4, because this was 0, we got only one value. But if I take minus 3 here, I have square root of plus minus 1. So plus minus of 1 will give me 2 values, which is, if I use plus 1, then it will be 2. But if I use minus 1, then it will be 0. So that minus 3 gives me two values because of this plus minus. Do you understand this part? Because square root of 1 plus minus 1, if you do with 1, you get 2 or 0. So when I'm plotting this point at minus 3, 1, 2, 3, then I get 0 or I get 2. You get the idea. Let's go one more step to understand this process, right? We know square root of 4 is 2. So we'll take the next value as x equals to 0. Now if I write 0 here, then we get plus minus 2, right? So what we are getting here is 1 plus minus 2. So we are getting two values. Do you understand? If we substitute 0, we get plus minus 2. So the two values are 3 and minus 1, right? So at 0, we are getting two values which are 3 and minus 1. So 1, 2, 3 and minus 1. Do you see that part? Correct? One more value so that this point is absolutely clear, as this has been a confusion for many students. So I'm taking a good points here. I'm taking 5. 5 plus 4 is 9. So what we get here is we get 1 plus minus 9 means 3. So that gives you two values. 1 plus 3 is 4. 1 minus 3 is minus 2. So at 5, we are getting 4 or we are getting minus 2. So two values. Does it make sense to you? Now we can sketch this graph. So let's sketch the graph. So we have this. So this is a round corner, right? And here we go. Do you see that part? So we have a parabola which opens right. So you saw here that if your parabola is opening up, inverse opens right. So we see inverse open right. Mainly because this opens up, right? So that is what we get. Now the last part in this particular case is, so we have sketched the f inverse x. Let me write. State restrictions on the domain of x to make the inverse to be a function. Now, we know now the vertex here is 1 minus 4. So we could take one side of the graph of the function. So in part D, we'll make a restriction on f of x, that is, we'll say x greater than equal to 1. So that is the restriction. If f of x is greater than equal to 1, in that case, we are restricted to the upper half, correct? State restriction of the domain of x to make inverse to be a function, then the inverse will be a function, right? So that is the restriction which we made. Well, if I have to highlight this part, it will be highlighted as the upper half of this parabola. Since we are taking the right side, does it make sense to you? So f inverse x will be top part for the given restriction which I took, right? So this graph represents when f of x greater than equal to 1. Is that clear to you, right? So because if x is greater than equal to 1, we know y will be, in this particular case, is greater than equal to minus 4, right? So y is greater than equal to minus 4. You can see for inverse, it has swapped. Y is greater than equal to 1, right? And x is greater than equal to minus 4 for the inverse. Does it make sense to you? So I hope with this, all the concepts about graphing quadratic functions and their inverse must be clear. Perfect. Take a moment to go through these questions once again and try them yourself. I hope it makes sense. Feel free to write your comments and share your views. If you like and subscribe to my videos, that'd be great. Keep posting your questions so that we can really help you in the area you need. Thank you for your time and all the best.